Okay, so welcome to lecture 42, and we will continue with the canonical transformation. Okay, so in last lecture we have seen the point transformation, that transformation between coordinates, and how can be generated. So generating functional for point transformation, and then towards the end we define the canonical transformation. So let us start repeating the definition of canonical transformation, and we will continue. So definition of canonical transformation. So transformation between a old set of variables qi, pi to a new set of variable capital P, Q, K, where these P's are function of old canonical variables. Now not only the coordinates, but old canonical variables. Capital Q is also there can be many, so you can put a symbol. Q is also function of Qi, Pi, and T. Okay, so this transformation will be canonical transformation if the canonical equations are preserved. So with the Qi, Pi are canonical variables, and the Hamiltonian is H, which is function of Qi, Pi, and T. Now capital Q and capital P, they are also canonical variables, and I can have a new Hamiltonian. Let us denote with K, which is Qi and Pi with T. Okay, so this Hamiltonian is the new Hamiltonian in terms of new canonical variables. So the old Hamiltonian, the equation of motion was Qi dot del H del Pi, and minus Pi dot was del H del Qi. So that should preserve in the new Hamiltonian. So you will have Qi dot will be del K del Pi, and minus Pi dot will be del K del Q. Okay, so if we have this, then we will say that transformation is canonical transformation. Okay, and remember our the definition of Hamiltonian through the Legendre transformation. You recall that H for the old set, it will be Pk Qk dot minus L, which is Qk Qk dot and T, and the new Hamiltonian K will be Pk Qk dot sum over K minus L prime, which is Qk and Qk dot times T. Okay, so this transformation will be canonical transformation only when this preserve the canonical equation, and we try to find the condition for this transformation to be canonical, and for that we need to use this definition along with that equation 7, which I mentioned last time in last lecture, that Qi dot T, this Lagrangian is new Lagrangian, which is Qk say Qk dot and T plus df Qi and T dt. Okay, so let me put some equation number So I hope now situation today's equation number in this lecture. So let me write transformation. So this we can write 1 and this we can write 2. So canonical transformation is transformation going from one phase space, the old phase space, to the new phase space through a transformation such that equation of motion, canonical equation motion preserves. That means in terms of new Hamiltonian and new variables, you will have the same form of equations. So then the transformation will be called canonical transformation. Now we are trying to find that what will be the condition to check whether a transformation is canonical or not. For that we need to use this equation, this the Lagrangian changes by a gauge transformation which does not change equation the dynamics, and also we have to use the definition of Hamiltonian through Legendre transformation, which I have written in equation 1. Okay. And F will be, as we will see in the case of point transformation, we will also see that probably the F will play the role of generating functional for such transformation. Okay. So let me later we will see there will be many F, many possible generating functional. So let us start that this is F1. So let us, this is first type of thing. So let us write F1 to make it distinct from the others. Okay. Now start with this equation and we try to calculate del F del 2. So this, let me simplify the right hand side will be L prime qk dot t plus del F1 del t plus, this is only one variable t, so this is partial derivative, but now I can differentiate del F1 with respect to qi, and then qi will be differentiated with respect to dot. So qi dot sum over I plus del F1 you can differentiate with respect to qi and qi dot. But remember, we have to I forgot to mention, but remember we are making we are not considering the point transformation, we are making a transformation of the canonical variables phase space. So we have to go to the Hamiltonian form. So we have to use equation 1 for both L and H. L and L prime. Okay. So what we can write is that what we can substitute this that L and H. So left side L will be substitute as sum over p small p k qk dot minus L will be minus H qi pi and t. Okay. So if I substitute this, and then for L prime we will substitute that sum over k p k qk dot. This sometime it may be confusing to write small p and capital P, but I hope you can make it difference between them, because small p in the old set of canonical variables, capital P in the new set. Okay. So this minus L prime qk dot t, and then you have this del F1 del t plus sum over I del F1 del qi dot plus del F1 capital qi dot. Okay. Let us write the new Hamiltonian. We want to rearrange this. So let us write this is my new Hamiltonian. So in the left side, so you will have the new Hamiltonian K. So this we don't need the explicit form of K here, so K I write, and then we substitute the old. So it will be minus Pk small qk dot plus h qi pi and t plus plus del f1 del t no let me check because the Hamiltonian we expect to be the function of okay, just a minute, we have some mistake we have done here, so let me figure it out. Here the mistake is here, mistake actually this is the mistake. See, we are substituting from equation 1, so this should be k. L prime we are substituting, see this L prime we are substituting. So let me do this last step again. So I am sorry, this so the up to this is okay, this substitution okay, so let me erase the full equation because this okay, great, and the correct thing we write with the black pen. Okay, so you have, let us substitute. So L will substitute, so this is L is qi dot and t, and then let us substitute L and L prime from equation 1. So L is basically, L is sum over pk or I qi dot minus h. L prime will be sum over p capital P, now capital P qk dot and minus k. So I have substituted L and L prime, nothing else, so no confusion now. So f1 del t plus the sum over del f1 del qi qi dot plus del f1 del qi dot. Okay, now I that is fine, and so what I want to write this k here. So new Hamiltonian k in the left side, so it will come with the minus sign, it will come with plus sign. Then this side we have p capital K qk dot, then minus p small pi qi dot, this is sum over I, this is sum over k. I could have written the same symbol, and then plus h plus del f1 del t plus the sum over I del f1 del qi dot plus del f1 del capital Qi dot. Okay, now we are fine. Okay, so now let us combine these two terms. So terms with capital Q dot, this is dot, this is also dot. So let us combine these two terms, and also I can write this summation is dummy variable. So sum over p capital Pi plus del f1 del Qi times Qi dot. these two, if I combine these two terms. Now let us combine this, let us combine small q dot term. So, this term and this term. So, I can write sum over I, then del f1 del qi minus pi and multiplied by qi dot, okay, plus h plus del f1 del t. Okay. Now, k, the this small q and capital Q, they are independent in that sense. So, their coefficient also will be 0. Okay. So, from here we get that making their coefficient of q dot and qi dot 0, we find. So, let us write. So, we find pi will be minus del f1 del qi and small pi is del f1 del qi, and your new Hamiltonian k will be the old Hamiltonian this plus del 1 del t. Okay. So, we find the condition for the, we find that how the transformation can be generated, not the condition, condition we will see later. So, we find that f1 can generate a transformation. So, what we have achieved here? We have achieved that f1 function of qi, qit can generate a transformation between the qi pi old set of canonical variable to new set of canonical variables, which is qi capital Pi, such that L equal to L prime plus df1 dt qit will be preserved, such that I can go from L to L prime, the Lagrangian L2 prime, which is connected by gauge transformation, and we know those are equivalent. So, we have found a generating functional with the properties. Also, f has the properties listed here. So, let us denote with some equation number, equation 3 for this lecture, equation 3. So, we find that f1 which satisfied this equation, this equation will be the if they satisfy, then we can go from L to L prime, which are related by gauge transformation and dynamics does not change. So, we found generator which can generate a canonical transformation between old set of variable to new set of variable, old set of canonical variables to new set of canonical variables, such that the Lagrangian is changes by the gauge transformation, does not change, and if that doesn't change, the dynamics doesn't change, equation motion will be preserved. So, at the Hamiltonian level, canonical equation will be preserved. So, we found a transformation which can generate a transformation between old set of canonical variables to new set of canonical variables, and the which connect the h and k. H and k are connected by the gauge, also the correspond to the gauge transformation which was connected L and L prime. Okay, so let us first consider, to realize this, let us consider that that this preserves the equation of motion. So, let us start with this. So, new Hamiltonian first, then we will see the exam. New Hamiltonian k is sum over say pi, capital Pi, capital Qi dot minus L prime, and this is nothing but Pi Qi dot minus L prime plus df1 dt. So, this is sum over Pi Qi dot minus L plus del f1 del t plus sum over I del f1 del Qi dot plus del f1 del capital Qi dot. Sum is for both the terms. Okay. Now, if we use the condition we obtain del f del small q1 and del f del capital Q1 here, then we will get Pi Qi dot minus L, which is function of Qi dot and t del f1 del t plus this del f del Q1 will be sum of Pi and Qi dot, and this will be minus capital Pi Qi dot. Okay. So, you can immediately see that if you have del k del q j, you will find minus p j dot. Similarly, if you have del k del p j, you will get q j dot. Okay. From this is clear. So, canonical equation also will preserve. So, now we will consider an example. Say suppose it is given that f1 is half m omega q square times say cot q. So, f1 is a function of small q and capital Q. Okay. So, this is the function given. So, let us see what kind of transformation it generates, and then we will see that how it can be helpful. Okay. So, it generates, suppose this f generates this. So, now I use the equation to generate transformation. P is del f del q. So, this will be m omega square q cot q. Okay. Similarly, minus p will be del f del q. So, which will be half m omega square q square, and cot differentiation will be minus cosec square q. Right. So, p will be, so small p will be m omega square q cot q, and capital P will be generated by this will be, so minus and this minus will cancel, and then half m omega square q square cosec square q. Okay. So, if you write simplify in favor of q, this implies q equal to 2p by m omega square then sine q, because cosec is the 1 over sine. Okay. So, now I claim that the f1 with this example generates f1 this generates a transformation p equal to m omega square q cot q and q equal to root 2 capital P m omega square sin q. Okay. So, this is a old set of variables and this is the q, p and q are new set of canonical variables. So, F1 the given form generates this canonical transformation right, which correspond to that L equal to L prime plus df dt in the Lagrangian formulation, or it k prime will be h plus del f del t. In this case the f does not depend on time, so k equal to h. So, your Hamiltonian does not change. Okay. So, this canonical F1 generates the canonical transformation of this. Now, let us consider if we apply this canonical transformation to a simple harmonic oscillator. So, if you generate simple harmonic oscillator, h equal to p square by 2m plus m omega square to q square. Suppose if I apply this to simple harmonic oscillator. So, after canonical this above canonical transformation, we obtain k, which can be function of capital Q and capital P, which will be p square by 2m. So, p square by 2m. So, p square let me write m square omega to the power 4 q square cot square q by 2m. Okay. And q also we have to okay. So, this is p square. No, I have to substitute p square. So, I am sorry. So, this we have to substitute p square. P square is 2p m omega square, then sin square q by 1 over 2m plus m omega square to q square. Q square will be just do a algebraic mistake. Actually okay. So, let me do it first. P square is m omega to the power 4 q square cot q. Okay. So, p square is, let me write, or maybe we cannot finish this in this lecture. So, we will continue from here. So, what we will do here, that we have seen F1 to generate a canonical transformation. Now, we will apply this canonical transformation to a simple harmonic oscillator, and I am going to show you that this will be helpful, or this will reduce the algebra to solve the system. We can find the solution of simple harmonic oscillator. Of course, simple harmonic oscillator is very easy to solve, but we will find that alternatively using canonical transformation it can be solved. So, maybe this example after this which you could not finish in this lecture will continue in the next lecture. Okay. Bye for now.